Isosceles triangles. So let's remember our congruent triangle postulates. We had angle, side, angle. And this one would be side, side, side. We have side, side, side. An isosceles triangle is a triangle where at least two sides are of equal length. If all three sides are of equal length, it's also an equilateral triangle, but it's still also isosceles. It can be both. The legs are the equal sides. The base is the side that's not equal, or the third side. Base angles are opposite the equal sides, and the vertex is opposite the base. So does everybody have these words? Okay. So this is the vertex. These are the legs, and the bottom is the base angles. A theorem that says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I draw any triangle, I'm going to draw it in a different space, like that. Let's say that's not right. Okay. No, that sucks. Because it won't do what I want it to do. So if these two legs are congruent, then the angles opposite those legs will also be congruent. And vice versa, if I have a triangle and these two angles are congruent, then the legs opposite those two angles will also be congruent. Okay, equiangular triangles are also equilateral, because if you think about that, let's say I have a triangle, right? And all of my angles are the same. Well, if I take any two, the sides across from them are the same. Well, so it's for all of them. So then that makes all of the sides the same. And vice versa, if I have a triangle where all the sides are the same, if I go across from any one side or any two sides, I get angles that are all the same.
So if they're all the same on
Yeah, if it's equiangular, it's also equilateral. You can't be equiangular and not be equilateral, and you can't be equilateral and not be equiangular. They're the same. So if all the sides are the same, all the angles will be the same, and vice versa. Does that make sense? An equiangular triangle, right? So I've got some triangle and all the angles are the same. They're each 60 degrees because I have three angles that are exactly the same. So they have to be 60 degrees. Does that make sense? And then if I have a nice isosceles triangle, nice isosceles triangle, right? And I come in with angle bisector. So if these are congruent, then this is the perpendicular bisector of the base. So that makes these congruent. So if you have two sides here that are congruent and you cut this angle in half, these are congruent and this line is perpendicular. If these two are the same, what do I know about these two? So these are both x, right? So this would be 2x. Yeah, so 2x plus 50 is 180. Or 2x equals 130. Divide by 2. And x is 65. Okay, so these are the same, so that makes these the same, so that makes this 5. Okay, if I have an equilateral triangle, what does that tell me about all the angles? They're the same, and if they're all the same, they're 60. C, if these are all four the same, that means all four of these angles are the same. And then that means these two are going to be the same. And there's two x's here, right? 1x, 2x. So that's going to equal 180. So 2x is going to equal 94. So x is going to equal 47. Yeah, thank you, 47. And then D, these are all going to be 60, so x is going to be 120. So I have been given that AB and BC are congruent, so that's given. Well, if the two sides are congruent, that makes the triangle an isosceles, right? That's the definition of isosceles. Well, if I have an isosceles triangle and the two sides are congruent, that means the two base angles are also congruent. Because, again, that's the definition of isosceles. That's one of the other definitions. And angle 2 is congruent to angle 3 how? Vertical angles. And if 1 is the same as 2 and 2 is the same as 3, that makes 1 the same as 3 because you can use substitution. Or transitive. No, it's either the substitution or the transitive property. Corresponding only occurs when you have parallel lines. Or in two different triangles. So it's either substitution or transitive. Either one of those words will work there. Yeah, rhombuses are hard to draw. I'm not very good at them myself. So it's close enough, rhombus, right? And you know, a kite, the shape called a kite, the kite that you fly was actually named after the shape, the kite. I don't know if you guys are aware of that. And then of course, you have parallelograms, rectangles, squares, Star Trek emblem on its side. So it's quadrilateral. A parallelogram is a special kind of quadrilateral where, come on. Opposite sides are parallel. So these two sides are parallel and these two sides are parallel. Parallelogram. Now, in addition to a parallelogram like this, a rectangle is a parallelogram and a square is a parallelogram. That's not a square. That is not a square. Fine. Okay. All right, so if I draw a parallelogram, opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. And the diagonals of a parallelogram bisect each other. Let me see if okay. Yeah, I'm going to label all that over here. Okay, so opposite sides. So BC is congruent to AD. So BC is congruent to AD. And AB is congruent to DC. So those are the opposite sides being congruent. Angle B is congruent to angle D. That's this angle here is congruent to that angle there. And angle C is congruent to angle A. So this angle is congruent to this angle. Okay. The diagonals bisect each other. So AE is congruent to EC. Right? So if I come in here and I do, those are congruent. And then BE is congruent to ED. So 1, 2, 3, 4, 1, 2, 3, 4. And that covers these. Now, bless you. We also get this really cool thing that the measure of angle A plus the measure of angle B equals 180. The measure of angle B plus the measure of angle C equals 180. The measure of angle C plus the measure of angle D is 180. And the measure of angle D plus the measure of angle A is 180. So any two angles that are connected by a side will add up to 180. And then, oops, I'm going to show you something else. No, stop it. I'm going to show you something else that's not part of your theorems, but just so you know, parallelograms with diagonals is sort of like a parallel lines with transversal. So this angle is the same as this angle. This angle will be the same as this angle. Let's do orange. This angle will be the same as this angle. And let's do purple. And this angle will be the same as this angle. So these opposite angles will be the same. Just something for future reference. It's not one of the theorems that we have, but it is true. Use that information to solve this parallelogram. All right, there's a lot going on here, right? Well, what we know is that this side and this side are congruent. And we know that these two sides are congruent. And that these two angles together will add up to 180. So congruent means they're equal, right? So you guys want to do x, y's, or z's first?
X, Y.
X first? All right, so these two angles are consecutive. Sorry, I couldn't think of the word. They one and the other, so they add up to 180. So if I take the two angles and I add them together, it will equal 180. So I get 10x minus 20 is equal to 180. Add that 20 together, both sides. Sorry. So you get 10x is equal to 200. So x is equal to 20. So there's x. And now I want to find y. Well, my y's, those two sides are congruent. So they are equal to each other. So subtract 3y from both sides. You get 2y minus 6 is equal to 4. Add 6 to both sides. 2y equals 10. So y equals 5. And finally, for the z's, I have these two short sides are equal to each other. So 5z is equal to 3z plus 8. So 2z equals 8. So z equals 4. All right, MNOP is a parallelogram. Given. Okay, I'm done. You guys do the rest. No? Okay. Angle MNP is congruent to angle OPN. That's this and this. Oops, wrong angle. And this. Right? MNP, OPN. I have parallel lines, right? Cut by transversal. So these are alternate interior angles. Okay. ONP is congruent to MPN. Same reason, right? Alternate interior angles. NP is the same as itself. You sure? Okay. These two triangles are congruent. Angle, side, angle. And if I say two triangles are congruent and then I say parts of the triangles are congruent, that's CPCTC. So I just proved that these opposite sides of this parallelogram are the same length. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So if I have some random shape and these are congruent and those are congruent, it's a parallelogram. If we have something like this, and let's call this ABCD, and if AB and CD are congruent and AB is parallel to CD, then it's a parallelogram. So you have to have one or the other. You either have to have all four sides congruent, or not, sorry, both pairs of opposite sides congruent, or you have to have one pair of opposite sides congruent and those sides are also parallel. Because if that's the case, then it makes it a parallelogram. That says if opposite angles are congruent, both pair, then you have a parallelogram. And then we have another theorem, and I'm going to use color on this. So if, let me change that. So if red plus blue is 180, then you have a parallelogram. So opposite angles are congruent, you have a parallelogram. If consecutive angles add up to 180, you have a parallelogram. So if I have this quadrilateral and then I do diagonals across it, and then this length is the same as this length, and this length is the same as this length, then that makes it a parallelogram. Okay, these are the different ways you can do to prove a quadrilateral is a parallelogram. We can prove that the opposite sides are parallel, both pair. We can prove that both pair are congruent. We can prove that one pair of opposite sides is parallel and congruent. We can prove that the opposite angles are congruent. We can prove that the consecutive angles are supplementary, or we can prove that the diagonals bisect each other. These are the different ways to get there. Okay. Whoa. To prove that these are a parallelogram, I can prove using the distance formula and the slope that these opposite sides are congruent by the distance formula, And then I can use the slope to prove that they're parallel. Or, does anybody really want to do the distance formula 4 times and the slope 4 times? Because that's what you have to do. Now, if you would not like to do that, what you can do is you can take out your graph paper. Okay. And I take out my graph paper and I give myself, hold on one second, let me pause. Okay, and instead of looking at this, what we're going to do is we're going to plot that on a coordinate, and it's all positive, right? Do you see how they're all positive? They won't always be positive, but since they're all positive, I don't really need to have much in the way of negatives, so I can put my coordinates over here. And I'm going to make each one of my lines 2 because, or sorry, 1. 2 lines will be 1 because they're very small and it's hard to see. So I'm going to plot my points 2, 4. So I go 1, 2, and then 1, 2, 3, 4. So that puts me here. And 0, 0 is here. And 6. 1, 2, 3, 4, 5, 6 is here. And then 7, 8, 7, 8, 4. It's right there. And now I'm going to connect my dots and make my parallelogram. Or, well, I'm going to make my shape, my quadrilateral that I'm trying to prove is a parallelogram. Okay. Now, I could figure out the distance between these 2 points and the distance between these 2 points and say that it's the same, and then I could find out the slope of both lines to see that they're parallel, and etc., etc. Or I can count how many spaces up I move versus how many spaces over. So I'm going 1, 2, 3, 4 up, and then 1, 2 over. And if I come here, I'm going 4 up and 2 over. That means this length is the same. It also means that the slopes are the same. Now for this distance, I just count because it's a flat line, so I just go 1, 2, 3, 4, 5, 6, and then I do the same thing. 1, 2, 3, 4, 5, 6. So this length is 6, this length is 6, and here I went up 4 over 2, up 4 over 2. So yes, it is a parallelogram. If x, well, okay, 70 and 1/10, so what's x have to equal? And what does y have to equal? Okay. Now this one's a little bit more complicated with the x's, but for y, what does y have to equal? 31. Now x, I don't know what x equals, but I do know that this is 26 right here because that was 26. And this is 117 because that was 117. And then this is also x. And I know that x plus 26 will make up this whole angle right here. And that's 117. And these two angles have to add up to what? 180. 180 is kind of like always the magic number, isn't it? 26 and 117 is 143. So 37 degrees. So I'm using my graph paper. To get from this point to this point, I'm going to go up 4 over 3. And same, I'm going to go up 4 over 3. And the distance between these two is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that one's a yes. Does that make sense? The part gets a little confusing. I'll rewrite that. Oh, darn it. Okay. Let's try the next one. B. 1, 2, 3, 4, 5, 6. 3, 7. 5, 12. 8, 9, 10, 11, 12. And 3, 11. 7, 8, 9, 10, 11. Okay. To get from this point to that point, I'm going up 1, 2, 3, 4, 5, and over 1. And to get from this point, I'm going up 1, 2, 3, 4. No, 5. Sorry, 5. But I'm going over 2. So I go up 5 both times, but I go over 1 once and I go over 2 the other time. So I don't even have to do anything else. It's not, they don't match. So it's not a parallelogram. So up 5, but over 2. They left a line out. They need to say MN and QP are parallel, but it's fine. Definition of parallelogram again. Because the opposite sides